Okay, let's get started. So, hi everyone, good morning. My name is Avishay Balter. And why am I here? So I'm here because, professionally speaking, I wear two hats. So on the one hat, I'm an engineering manager for an incredibly talented, multidisciplinary team of software engineers, data scientists, TPMs, security SMEs, data SMEs, design thinking SMEs, and we engage headfirst, keyboards on the ground, with some of Microsoft's top strategic accounts. Chances are, if you heard about an exciting collaboration between Microsoft and the industry leader in automotive, in healthcare, government, most chances are my team or one of our sister team across the organization has been there leading the engineering efforts. And my other hat, I'm a co-chair of both the Best Practices Working Group and the Memory Safety SIG within the Open Source Security Foundation. And I want to share some of the learnings between these, the symbiotic relationship between these two hats, and how tools that are provided for free can help your organization and mine to do better with security. So let's start with an interactive exercise. I want to see with a show of hands if there are any maintainers of open source projects. So that means that you are part of a core team which maintains an open source project. Anyone? OK, a couple of hands. Anything we heard of? No. OK. Still, let's give them a round of hands. Thank you very much for your amazing projects. We love them. So now let's see contributors. So you opened a PR or two, you fixed some documentation, you opened an issue for an open source project. OK, obviously, a little bit more. Maintainers, give them a hand, right? Because we definitely depend on them. Please, next time, also suggest a fix. And last, consumers. So do you consume open source? OK, so that's easy, right? Now let's then ask a data-driven question. How did I know to come to any IT conference and ask these questions and get such an immediate response? What is the base ratio, right? What is the underlying probability that any one of us is using open source? Or put in another question, how many of the code bases in the world actually contain open source? Anyone here has a guess? Most. Is it 80%? 90? 5 nines. 9.99. OK. 90. So actually, 97%. Wow, OK, big number. And that's actually the number for 2024. The recent one shows 98%. I didn't put it in because, 97 is enough of a number to put you on the edge of your seats, right? So of these 97%, how much of the code do you think is actually open source? And this was actually referred yesterday also, the same statistic in my friend Neil's presentation. 50%, you say? More? OK. 80%? Yeah, OK. So around 80%, 77% of the total weight of your app is open source. OK, so that means that if we put it in a nice kind of donut pie chart, your code is the green part. And the rest of the chart, the rest of this pie, is all of your vendors and suppliers. This is the volume of the supply chain. Now let's do something fun. I'm an engineer, a software engineer, so this is sometimes hard for me to think as an attacker, right? Because then, as engineers, we think about how to make things work, how to improve things. As an attacker, we would do exactly the opposite. We would try to break it. So here is a classic data flow diagram, right, of an app. This one sits on GCP, but it's obviously the same for any kind of app. How would I attack it? I can impersonate the user. I can do a man-in-the-middle attack. Maybe I can directly attack the database. But let's think about it in a different way. right? Because actually, every one of the components that you see here, those that you've written and those that you are leveraging, the WAF, the underlying infrastructure, the cloud infrastructure, everything here complies to the same ratio. Your code, your configuration, your IAC, everything is just 20% of what you see. The rest and the biggest attack surface is your suppliers. And this is the reason why we see the surge of attacks rising over time. Starting in 2019 with the, everyone knows the Log4Shell, and multiplying every year, we see attacks on open source repositories rising. And if you think that these numbers are going to decrease, then maybe it's a bit of a naive way to look at how AI is being leveraged also for adversary uses. And it's not just the numbers. It's also the sheer sophistication. If you look at something like the XZUtil attack, this took over 2 years of planning, executing, moving from one repository to the other, neutralizing controls that might have detected the attack earlier by going to the fuzzing repository and disabling one of the checks. So this is why when we look at the software supply chain, this was dropped quite a few numbers over the last couple of days. This is what it looks like, right? We either produce code, we consume code, and that keeps the chain linked until it reaches the user. Now, obviously, this is a very, very simplistic kind of way to look at it, because I don't have one dependency. Typically, I have 5, 10 dependencies. Each one of those is another chain. Those will have 5 to 10 other dependencies. In the end, if you look at something like a software bill of material, which describes this dependency tree, this is how it looks like. Okay, so this is the complexity of the software supply chain. And now, the most important question. If something happens, if an exploit of a vulnerability somewhere down your dependency is being exploited, who pays? Who stands to pay the highest price? Obviously, it's the user, right? And here is the user wishing that he was the user of a different app, not your app, one that wasn't breached. And this is why when we ask ourselves, the developers, data scientists, TPMs, why do we even care about security? We have security guys to do that? No. We care about security because we care about our users. We love our users and our consumers, and we want them to love what we provide for them. And these users, you know, they have expectations, right? They expect that the software that they are using is secure enough. They expect that their data is being handled privately. And their expectations can turn into enforcement. For instance, in the UK, in the EU, in the US, everywhere across the world, these expectations are today being manifested into enforcement. And the next talk is going to be by Roman to talk about the CRA and one of those enforcement mechanisms. And of course, they should enforce it because these exploits actually cause harm. They cause harm to users, they cause harm to your organization, and they cause harm to you. And that harm has cost. Everything that you could fix early would cost you much more to fix in a post-incident mitigation. Now, I know, you're probably thinking, okay, is that really my problem? And I'm here to tell you, yes, it is. But it's not only your problem, it's everyone's problem. It's tech industry problems, it's healthcare industry, it's financial services problem, it's everyone's problem. Cloud providers, right? Everyone worries about the same thing. And this is why all of the organizations that you see here are funding both in money and in resources and code contributions to the Open Source Security Foundation that lives under the Linux Foundation. our mission to improve the security of open source ecosystem by advocating for secure software development practices by providing tools. We have 10 different working groups, best practices working groups, AI/ML working group, global cyber, etc., and different projects. Some of them, you probably heard of. Scorecard was mentioned already a couple of times, and I'm also going to mention it. But also Salsa, SigStore, Guac, things that are starting to gain traction. And really, wherever you are on the software supply chain, whatever your role is within that software supply chain, we have a working group, we have a project, we have tools that you can use for your work. And that brings me back to my position at Microsoft. Because as I mentioned, this is everyone's problem, and this is a cross-industry problem. And our teams meet customers where they are. Obviously, many of them, all of them, use open source and contribute to open source. We ourselves, as Microsoft, contribute quite a lot to Microsoft, and my team, for instance, maintains several projects that empowers organizations to trust cloud and Gen AI projects more easily. One of those projects is Presidio. Presidio is a very, very popular Python package that identifies and anonymizes PII information. And I love Presidio, but I'm not here to talk about it. Instead, I'm here to talk about this metric that you see here on the bottom. Now, this is a screenshot from the official Microsoft Open Source Program Office portal. And you can see here that every Microsoft package that we release, every open source project that we have, is being monitored for the OpenSSF scorecard result. And you can actually see the history of results over time. So let's maybe talk a little bit about Scorecard. It's been mentioned, so I'm going to skip it quite a bit. It's a very cool tool. You can run it through CLI. You can run it through Docker container. You can run it from a GitHub action. And it helps protect against different threats. The way that it works, it runs several checks that run across different security threats in a supply chain. Each one of those checks will have its own risk level. Risk level determines the weight of the score in the overall sum of the scores. In the end, you get a result of 0 to 10 for each one of those and for the entire repository. Use cases. As a maintainer, you can assess the security posture of your own project. As an organization, you can do the same as a Microsoft Program Office does and monitor your entire organization's open source. Now, we don't mandate a minimum, right? But we surface this information for developers to improve upon. And last, as a consumer, you can check the dependencies that you use. Now, let's see how that looks. And folks already presented a number of ways to use Scorecard. I'm going to do something a bit different. So our team obviously leverages quite a lot of AI for our work. And one of the things that we experiment quite a bit on is how to improve AI for better code. And what we found is the more tools that you provide your AI, the better your results are. In this case, I provided Scorecard as an MCP to my agent. And then I asked it to analyze this project and to provide me a plan forward, right? So in this case, I'm a persona of a security project manager, and I want to understand what to do next. So the agent ran it, and then it found some critical issues, medium issues, and some good pointers. Thank you very much. And then it offered a plan forward. Sprint 1, I want to remediate known vulnerabilities. Sprint 2, I want to enable branch protection, restrict my workflow token permissions, and lock my dependencies to specific versions. OK, let's remember this. We're going to talk about that in a little bit. Sprint 2. Again, GitHub API informed the scorecard that I don't mandate a code review. CI tests don't run all on PRs. And I don't have a package. I don't package my my output. And also, I'm not signing my releases. Great. Let's take this one step forward and also examine my dependencies. How are they looking at security? And this is something that is real life. We, for every dependency that we take with our customers, we examine how do they look at security. So again, analyze all the dependencies in the project. Python, NPM, everything, and tell me what are the gaps. So you can see that it ran Scorecard on MCP, the Python package for MCP, LangChain, Chekhov. So it ran all of these, all the dependencies, and then it provided me an overview of my supply chain security. So Chekhov, MCP, LangChain, everything, and let's maybe look at, OK, so my overall systematic security gaps. No one is pinning dependencies, OK? Unsigned release for most of them, inconsistent branch protection. So this gives me a better view of my real supply chain posture. And it also provides a remediation plan. Great. Now, I've talked about the different checks. Now, actually, Scorecard has maybe 18 checks, and it has also additional experimental probes. So let's ask, again, the agent, what are the probes? So the agent suggests that we have 18 security checks. Great. And we have probes. Some probes are stables. Those are used to implement the checks. And some probes are experimental. So those are new features of Scorecard that you can also use. For instance, do I have an SBOM? For instance, do I have unsafe block? So this is quite new. This is a memory check that is being performed by Scorecard, and it identifies Go and C#. So that's weird. Maybe let's double-click on that in a little bit. Cool. OK, so a couple of things we've seen. So one of the things that we've seen LangChain. Now, LangChain was raised as a medium risk. Now, I can tell you a secret. A couple of months ago, that wasn't the case. Now, one of the things that we at Microsoft noticed is that many customers obviously love LangChain. It's a beautiful package. Many people use it. However, its security posture had improvements to be made. So because we wanted our customers to deploy their AI, Gen AI projects securely on our platforms, we invested in that money, resources, and together with the OpenSSF Alpha Omega, which actually addresses the critical projects in open source, we funded the security improvement of LangChain. Now, another thing that came up is pinning dependencies. So let's talk about that for a little bit. So pinning dependencies is actually one of the most critical checks that Scorecard has to identify security risk. You can see in this chart, it's actually number 3, right after code reviews and binaries in your code, which are a big no-no, but also pinning dependencies. Pinning dependencies can help you, 1, get reproducible build, and 2, reduce the exposure when one of your dependencies has been compromised. Now, one of the things that we did with the NuGet team is to identify how does the NuGet ecosystem treat pinning dependencies. And as you can see, not great. Very few had the higher score. Most had 0. And about the same number had -1, which means that something wasn't supported. So we wanted really to target those two lower scores. And this is what we've done. So we actually collaborated between the NuGet team and the OpenSSF Scorecard team. You can read more about this in this blog post that we shared about how that actually looked. But what you can already use in Scorecard is, one, check that you are locking your dependencies when you do restore. So if your GitHub action, if any of your shell script or your Docker container runs NuGet restore minus locked mode, will get you the high score. Not using locked mode, lower score. Same if you are doing NuGet install or .NET add in any of your scripts, GitHub actions, whatever, it'll detect it. You can actually do it better if you define restore locked mode in your CS proj, and it will still be detected by Scorecard. Or you can use the newer version of .NET, which uses CPM, Central Package Management feature, with a specific version, which is the square brackets around the version. Any of those will get you the higher score, and more importantly, pinning your dependencies in .NET. Now I want to touch a little bit about memory safety. Memory safety is important. Anyone knows why is it important, how important is it? Or maybe we can ask how much of the vulnerabilities in the world are memory safety related. So this means access errors, this means overflows, buffer overflows, uninitialized variables, all of these. 50%? 60%? Okay, so actually 70% of the world CVEs are memory safety related. And actually, the question of is my code memory safe or not is harder to answer than you think, right? Because, come on, everyone knows the promise, right? And this is taken from the most recent Rust in Android report, and it shows, act surprised, that when you reduce the number of C and C++ code and replace it with Rust, you reduce your memory safety issues. OK, so that's not a big shocker. So let's all go on Twitter now and say, let's replace all of our C++ code with Rust. Right? Should we do that? OK, we shouldn't. Right? And actually, it's not even a real-world scenario. It's not even a reality that we can actually think about, right? Because we have so many dependencies. And more than that, I argue that the question of is my code memory safe or not is not a binary switch. I can't answer it with a simple yes or no because it is a continuum, right? And it's a continuum no matter what language you use. Because let's take two examples. Let's take Rust, right? And put everything in an unsafe block. And all of your code is here within a big unsafe block. And then take C++, modern C++, fuzzed, everything, the most secure that you can think. Which one of those is more secure? This is an academic question. And we don't care about that, right? Because we are here to write code. So let's understand how does that actually look in. So actually, there is a continuum which you can be on, which is going between the most ideal and least ideal. Now, let's take a look at C#, because that was part of the memory safety blocks, one of the memory safety probes that we've seen, and try to understand the unsafe nature of C#. So actually, unsafe C# was there from the beginning, because sometimes you need unsafe code. However, the more modern C# got, the less unsafe code you actually need to use. And it's not only that you're unsafe or safer, it's actually that you also are better at performance. So some of the evolutions that allow you, for instance, C# 7.2 added the ref read-only and the ref struct. It added spans, right, which enabled you to do in-memory slicing, super powerful features that you used to do with unsafe code blocks. But now you don't need it. So this is why the only question that matters is where are you on the continuum and how do you improve moving forward. Now, if you want to read more about it, again, this is an article that we wrote as part of the OpenSSF, this one done by the Memory Safety SIG, where we go exactly into the discussion about changing how we talk about memory safety. Now, if you want to join our next effort in the Memory Safety SIG, I invite you to join our calls and talk about the next frontier. How do you interface securely between memory safe by default and non-memory safe by default languages? Think about Python to C. Think about Rust to C++, right? Those interfaces, those boundaries between languages are where typically memory safety issues arise, and this is where we intend to provide the next guidelines. So we have folks from different organizations joining us, and I invite you to do the same. Now, I want to go back to the software supply chain, because we talked a lot about Scorecard. So Scorecard actually sits here, right? It helps us identify which kind of dependencies we take into our code. But I want to ask a question. Is this actually how the software supply chain still looks? And I argue that no. And we also seen an example. Because recently, 2 years ago, we started using more and more agents. And the more we started to use agents, we also gave them more power. And the agents started interfacing with our build system, with our code system, with our build system. We just saw an example of how the agent helped me identify which dependencies to take. And we also see agents being used to operate our release system, right? Our Kubernetes clusters, etc. And this is a problem, right? Because these agents can turn quite evil on us. And it's not just us, the developers, right? It's the data scientists, it's the TPMs, the BPMs. Everyone is using those agents, and these agents have these accesses, and we need to understand what can we lose. So obviously, we can lose a lot of our assets, our source code, secrets, our security plans. All of those things are being aided and accelerated through the use of AI, and we stand to lose the ability to maintain them. Some of the potential risks of using AI include, so for instance, the AI can propose a design which isn't secure enough. It can propose code which isn't secure enough. We can intentionally or unintentionally paste secrets or things that we don't want to the AI. A malicious attacker can craft a prompt that can trick the AI to do something that we don't want it to do. Or the worst, the AI can hallucinate, or as we typically call it, false positive on a code and generate hallucinated code. So let's maybe talk a little bit about those. So obviously, we all know that the AI always has an answer. It never comes back and says, I don't know. Instead, it always gives an answer, which is not always the answer we want, and most typically, it's not secure. So why am I saying that it's typically not secure? Let's maybe go into that. How many of the packages do you think that were suggested that didn't really exist, that were hallucinated? 10%? 1 in 10? More? 1 in... OK, so 20% of the repositories that were suggested, this was in previous generation of 4.1, GPT 4.1 was checked in this case. 20% of the packages, 1 out of 5, was purely fictional. And it doesn't help when malicious actors actually detect those hallucinated packages, go on and create those packages, and then we consume those packages because the AI suggested them to us as well. This is what is called slop squatting, right? When we consume a malicious package that was hallucinated by the AI. let's talk about a different thing, about skill degradation. This was also a topic in a very, very interesting talk yesterday. How many of the candidates that were asked to use code were writing vulnerable code if the control group was 7%? 2 times as much? 3 times as much? How about 5 times as much? 5 times as much people wrote vulnerable code when they were using AI. Now, is it all bad? We can't use AI for development? We can. So let's think about how much can we actually self-improve here. And here, actually, the number is larger than you think. 75% increase in secure code was done through the right way of using AI. For instance, self-improving prompts, the technique that is called persona as a security, as an expert, doesn't work, right? We're past that. Today, we use things like RCI, recursive, I keep forgetting, something. So using the AI in a recursive mode, using tools, right, to improve its own code. And what you find interesting is that actually different models act better at different stages, right? So for research, we use, for instance, Gemini, right, or GPT-5. For code implementation, we would use something like Claude. And for the recursive criticism, we would use something like, again, GPT-5, which is a very kind of critic model. Now, again, all of these, you can learn more about them in this guide, which is the AI Assistant Instruction Guide, again, by the Open Source Security Foundation. And this is actually a collaboration between the Best Practices Working Group and the AI ML Working Group. You can also take the prompt that we provide here and use the actual guide as a meta prompt for generating your own prompts. Now, if we are talking about guides, some other guides that you might find helpful are the concise guide for developing more secure software, or how to assess open source software for security, or the other that are mentioned here. And if I've already mentioned the AI ML working group, other very interesting work streams that are happening in that working group include SafeMCP, which does an MITRE attack framework assessment on top of MCP servers. Sorry, that's not the right slide. Learning more about secure development and all of the different practices that I mentioned can be done in this course, which is the Secure AML-driven development, also free course. And the OpenSSF AI/ML working group works on SafeMCP, MLSecOps white paper, which details the different components of a secure ML operation, and of course, model signing, which is already released. Other education content, which the foundation provides, includes developing secure software, security for software development managers, and the Secure AI/ML development guide. Now, I want to take a chance to look at this in a different way, right? Because actually, when I started contributing to the way that I started contributing to the OpenSSF is by consuming, right? So the first thing that I consumed is the developing secure software. I can't recommend it enough for any developer. And this actually started this relationship, which I started my presentation with, right? So these two hats, right? And this symbiotic relationship that they have, what I learned is that the more that I nurture this symbiotic relationship between these two hats, the more that I'm able to grow. The more that I'm able to leverage the work that I'm doing in the Open Source Security Foundation in my work at Microsoft, the more that I'm able to grow my my role and my impact within Microsoft. And the more that I'm able to grow at Microsoft, the more that I'm able to meaningfully contribute to the Open Source Security Foundation. And this is why my call to action, and the main driver for this, is for you to get involved. Now, there are many ways for you to get involved. It can be in the Open Source Security Foundation, it can be in the CNCF, other Linux Foundation channels, Apache Foundation, whatever you want, you can contribute to a better ecosystem and to your own career. So way to participate in the Open Source Security Foundation, you can find us here. We are a very diverse and inclusive bunch. We meet, every one of those SIGs and working groups meets fortnightly, and the calls are open. You can find us in the public calendar or on social media. So whatever you're using, we're probably there. And if you're on LinkedIn and you want to ping me and talk about career or security or AI, feel free to reach out. And thank you very much. Any questions?